Hi folks, we're going to take a look at the solution to page 90, number 16. So what they give us is three vertices of a parallelogram, and they want us to find the fourth vertex. Okay, so again, I'm going to draw a diagram. I don't want to rely too much on the diagram because it's not like I can just, take a ruler and measure anything here, but I'll make an effort to maybe make it a little precise here, again without drawing a Cartesian plane. So let's say here we've got 5, -3 for A. Okay, so we've got 5, -3, and so here we've got -2, 4, so we know that it's going to be to the left because of the -2, and it's going to be up because of the 4. So we've got -2, 4, so B is -2, 4. Okay, and then we've got C, so -1, so still a little to the left, but even further up. So we've got C is, somewhere up there, -1, 7, and I don't worry too much about making it precise. So remember how this has to be joined up to A, B, C, D. So first you join A to B, B to C, okay, and then D, and then back to A. So I know that my point will be somewhere there, so let's try to draw it as nicely as we can. So it's going to be parallel and the same length as that other side, okay, but I don't know what this point is, but I know it's a point on the Cartesian plane. So when I don't know something on the Cartesian plane, I need two variables to represent it. I'm going to use X and Y. Okay, now there's probably quite a few ways to solve this problem, so I'm just going to talk a little bit about some of the ideas that might come about. It doesn't mean that you're necessarily going to go with the first idea you come up with. So the first thing I was thinking of is I thought, well, parallelograms, we know that opposite sides are parallel. Okay, so I might think of, saying, well, hey, let me find the slope of this line here. So, the slope of BC is equal to 7 minus 4 over -1 minus -2, so that's equal to 3 over -1 plus 2. Oh, that's just 1, so the slope is 3. So this is going to have to be equal to the slope of AD, okay, which is given by y minus -3 over x minus 5. So I know that this slope has to be equal to that slope. Problem is I have an equation, but I have two variables. And I think, well, wait a minute, what if I solve a system? Maybe I could take this equation in two variables and use a second equation that has x and y. And that's when I remembered, oh, AD and BC also have to have the same length. So I could use the distance formulas, but this is where I'd say, you know what, I might back off on that method, because the distance formula has squares and square roots, and we haven't really found ways of solving equations with all those different operations in it. In fact, technically, to solve that, you'll need some algebra that we're going to be covering later on in the year. So I'm going to scrap that idea. I think it could work, but I think it's a little beyond this course. So let's come up with another idea. So again, this idea that these two sides are parallel, but those two sides are already parallel, are also parallel. And then I realize, hey, this point D is the point of intersection of these two lines. Okay. Now, can I find equations for these lines? Well, I can find an equation for this line here because I have a point, and I know the slope is going to be the same as this one here. Now, can I find the equation of that line? Yes, I can. I know a point on the line A, okay, and I also, it's parallel to this line there, so I can again find the equation and then solve for a point of intersection. That's not bad. So let's do that way, but I actually think there's an even nicer way. But just to show you that there's different ways to solve this problem, and I think they do ask us to check with two different solutions. So this looks a little more reasonable than the original one. So let's start by finding the slope of BC. Okay, so that's going to be 7 minus 4. Well, actually, we just found it above, so 7 minus 4 over -1 minus -2. Okay, sorry about that. So 3 over 1 is 3, and we know that this is going to be the same as a slope for this line here, but instead of actually trying to calculate x and y, I'm going to find the equation of this line. Okay, so y equals mx plus b. Okay, so I'll call this line 1. Okay, that's what I'm looking for. So it passes through 5, negative 3, so y is negative 3. The slope has to be 3, x is 5, plus b. So here we have b is equal to negative 3 minus 15, so negative 18. So equation 1, my first line, is just going to be y equals 3x minus 18. So now I'm going to find line 2, because that's the one that's going to intersect with line 1 to give me the point I need. So to find the slope of line 2, well, it's parallel to BA. So let me find the slope of BA. Okay, so here 4 minus negative 3 over negative 2 minus 5. So what do we have? We have 4 plus 3 is 7, and negative 2 minus 5 is negative 7. So the slope here is just negative 1. So now I can find the equation of line 2 because it passes through negative 1, 7. Okay. So y equals 7. The slope is negative 1. The x value is negative 1 plus b. So 7 equals, that's going to be 1 plus b. So b is just equal to 7 minus 1 is 6. So equation 2 is y equals, slope was negative 1, so negative x plus b, which is 6. And now I can just solve this system of equations. But hey, I already have the same coefficient in front of both of the y's, so I actually don't have to do any multiplication. So here, negative x plus 6, I can just subtract these two equations. So y minus y is 0. 3 minus negative 1 is 4x. And negative 18 minus 6 is negative 24. So 4x equals 24. X is equal to 24 over 4 is 6. So now let's find the y value. Y is equal to, I'll use this one here, negative x, which is 6. Okay, plus 6, hey, that's just equal to 0. So it looks like the point of intersection between these two lines, which is the d value that I'm looking for, occurs at 6, 0. So my d should be equal to 6, 0. And there you go. There's the equation. Okay. While it took a few steps, I really do think it would have been much easier than trying to solve the system of equations with the distance formula. Okay, and that's great. That's great. But I actually think there might be an even easier way to solve this. Okay, you might sort of think, why didn't I show you this first? But it's good to see that there's different ways to solve these problems. And I want to focus again on these two lines and the fact that they have to be parallel and the exact same length. Okay, and what I'm going to do is I'm going to use the idea that the slopes are going to be the same. That means the rise and the run. Here, I'm going to draw the rise and the run. And not only does the ratio of these two sides, which is what we are finding when we find the slope, have to be the same as the ratio between these two sides. Okay, the side lengths have to also be the same, because not only do these two sides have the same slope, they're also exactly the same length. So here, what's my run? Well, it's negative 1 minus negative 2, which we already calculated before is just 1. And what's my rise here? My rise is just 7 minus 4, which is equal to 3. So that means for this side, I need a run of 1 and a rise of 3. So that means that this x value here is just going to be 5 plus 1. My y value is just going to be negative 3 plus 3 in order to get the same rise. And lo and behold, what do we get? X equals 6, y equals 0. So D is equal to 6, 0. Heck of a lot less work than this solution here. Okay, this is a more intuitive solution. This is using our knowledge of analytic geometry and finding equations of lines. Okay, so just to recap, when you got a question like this, first thing is try to draw a diagram to set yourself up. And if your first idea doesn't look like it's going to work or be reasonable, you have to look for other methods. Okay, think about all the things you know about the particular shape, in this case here, parallelogram, about equal sides and parallel sides. Okay, that's it for this one.